Today we continue our lecture for section 4.4 and we use our Laplace transformation for solving equation. I show you two examples. Example number 1, we have this kind of differential equation. Oh, it start working. Sorry, it's take longer time. Now, x second derivative plus 4x first plus 13x equal t exponent negative t. Its initial point, value your function for 0 equal 0, and value derivative your function is 0.0 equal 2. Use Laplace transformation for this equation. We have s square x depend s minus 2, because we have value derivative is 0 is 2, plus 4s x to the s plus 13 x to the s. And right part our equation is, because our function is t and we have multiplied by exponential function e exponent minus t, we remember Laplace transformation from t, it will be 1 over s squared, but because we have multiplied by in exponential function, we have moving. This means 1 over s plus 1 square. Factoring right part and move our 2 in the factoring our left part and move 2 in the right, we have x to the s equal, well, multiplied by s squared plus 4s plus 13 equal 1 over s plus 1 square plus 2. Divide by for our factor, we have x to the s equal 1 over s plus 1 square times s square plus 4s plus 13 and plus 2 divided by s square plus 4s plus 13. I'm dividing separately because my second fraction is almost ready, and first fraction I have very simple numerical. It will be use partial fraction, it will be easier found coefficient. And rewrite my fraction like 1 over s plus 1 square s square plus 4s plus 13. Usually we write like combination 3 fraction. One denominator first fraction is s plus 1, denominator second fraction is s plus 1 square, and denominator third fraction is s squared plus 4s plus 13. Because s squared plus 4s plus 13, how you can see, you cannot factoring with real coefficient. But here we're doing a little bit easier because it's take it less time for solving. I will write like combination 2 fraction. One is denominator s plus 1 square, and second fraction is s plus d. Denominator is s squared plus 4s plus 13. Because we did many times before, make it same denominator, then write coefficient for all same power s, and you have system with 4 equation with 4 variable. After solving, you have a equal negative 1 over 50, b equal 2 over 25, c equal 1 over 50, and z equal negative 1 over 25. Okay. Use this coefficient. We rewrite combination our function and continue work with x s. Now I clear a little bit. We need more space. Okay. And we have x to the s equal minus 1 over 50. Fraction, it will be s minus 2 over s plus 1 square. Plus 1 over 50. And then we have s minus 2 over s square plus 4s plus 13, and last fraction is 3 over, oh sorry, it's not 3, it's 2 over s square plus 4s plus 13. First fraction, we don't need any s in the numerical. We're doing our last our streak. Add 1, subtract 1, simplify, and then we have minus 1 over 50. And here I have 1 over s plus 1 minus 3 over s plus 1 square. Okay. Here, denominator s squared plus 4s plus 13, I can rewrite. Oh, now I don't need this coefficient a, b, c, and d. We use this fact. Okay, I'm clear. And see what happened with my s squared plus 4s plus 13. I can write, because I cannot factor in, this means I can write like sum 2 squares. And what this will be? S squared plus 4s show us it will be s plus 2 square. But if we distribute this, give me s squared, I have, plus 4s, I have, and plus 4. But I have plus 13. This means it will be plus 9. Okay? And this means we have 1 over 50 s plus 2 square plus 9. This means numerical I need s plus 2, but I have s minus 2. I write s plus 2 This means I'm add 2 and I'm subtract 2. This means now I have minus 450, and I'm this fraction I write it together with my last fraction, and then I have, if we work it together, we have minus 450 and plus 2. How much is it? Minus 450 plus 2, it will be 100 minus 4, 96, 96, 50, right? If I'm not make mistake, it's it. Okay. Plus, here is 50. This will be s plus 2. S plus 2 square plus 9. But looking at our numerical, because we have 9 coefficient here, this means looks like I have function sign, and this means numerical it need be 3. Numerical is 96. I write 3 here and 32 there. Now my function ready for use inverse Laplace transformation. Okay, and what is will be inverse Laplace transformation for my function x to the s? First term is, this means x to the t will be negative 1 over 50. First, inside first parenthesis we have 1 over s plus 1 is exponential function e to the minus t. 3 over s plus 1 square. Because it's square, this means we have 3t. This means minus 3t e to the negative t. Okay. Here is plus 1 over 50. S plus 2 over s plus 2 square plus 9. It will be cosine 3t. But because we have plus 2 every time, this means e to the negative 2t cosine 3t. Cosine 3t plus what we have here, plus 32. This is very similar. We have e to the negative 2t sine 3t. Finally, we're done with this example. I show you one more example. How you can see, hardest part here is prepare our function for we can use inverse Laplace transformation. Okay, I'm clean my board. Clear my board and see. Sometimes it's taken longer time than we think. When I miss my classroom, when we have a lot of space, more time, and I have contact with my student, but it's okay, we save our semester. Here we have x second derivative plus 6x first plus 18x and equal cosine 2t, and initial point is value my function 0.0 it's 1. Value derivative my function, and 0 is negative 1. Same method, use Laplace transformation for this function. We have s square x to the s plus 6 times, sorry, I'm not finished here. I did a mistake. Then we have initial point is non-zero. This means we have value function multiplied by s minus s minus value derivative of function, because minus negative 1, this means plus 1, plus 6 times s x to the s minus negative 1. Here we subtract value our function, plus 18, say 18 and write 16, 18x to the s, and equal cosine 2t, this means s over s squared plus 4. Simplify, divide, and we have x to the s is s cubed plus 5 s squared plus 5s plus 20, and all of them divide by s squared plus 6s plus 18. This is my first factor, and s squared plus 4. This is my second factor. Use partial fraction, separate, and solving coefficient. We have I did all this work for you. We have something like this. It will be, I clear a little bit because it's taken so much space. We have our function x to the s is 1 over 170. Here we have 163 s plus 796 over s squared plus 6s plus 18. I'm rewrite like sum 2 squares. It will be s plus 3 square plus 9, and plus 7s plus 12 over s square plus 4. Here we're doing same trick because we see we have some cosine and sine function, combination cosine and sine. This means we need separate. And we have, it will be 1 over 170. But remember, if you have cosine and if you have denominator s plus 3 square plus 9, and your numerical has s, this means you need exactly s plus 3. This means first term. What does give me? 163. Here I write s plus 3. This means I'm add, or I'm use part 796 here, and this will be s plus 3 square plus 9. But what is left over? Left over is 307. Okay, I write this plus 307 denominators will be s plus 3 square plus 9, but numerical it's need be equal 3. It's about this 9 coming. Okay. It's first we have s plus 3 there, and we have s plus 3 numerical. This is 3 because we have term plus 9. Okay, 3 here, and I'm divided by 3 there. Okay. Plus, oh, second is much easier. We have 7 times s over s squared plus 4. And then 12 over s squared plus 4. But I write this way, plus 6 times 2 over s squared plus 4. Because numerical, my last fraction, it's need be equal to. Now use inverse Laplace transformation. I see it's coefficient not so pretty, but it's okay. This means we have xt equal 1 over 170, 163. S plus 3 show me I have e to the negative 3c. First this will be cosine 3c plus, oops, yes, plus 307 over 3 e to the negative 3c sine 3c, and plus 7 cosine 2c plus 6 sine 2c. We're done for today. I'm showing you 2 examples. I skipped part when we solving linear equation. We did it a lot. You can use your calculator and found solution use calculator, or you can do it by hand. It's your choice. Only solving example, and this is differential equation. Okay, good luck. Send me question, please. If you have any question about homework, send me. Oops, I try close. Bye. See you.